The performance analysis of the different types of steel bracing for the reinforced concrete building. Abstract. In general, reinforced concrete building is mainly designed only to resist the gravity loads that acting on the structure. Therefore, while designing the moment resistance frame, engineers do not pay more attention to the earthquake loads that can cause the building collapse. This study is concerning about the retrofitting of the existing structure by using steel bracing system. So in this study, steel bracing is used as an active part of the lateral load resisting system of the structure. The main objective of this research is to check the performance of the concentric bracing system by using static nonlinear pushover analysis and static linear system equivalent method. This study is deeply investigating the comparison of the different types of CSB system to reach one of the most effective during the earthquake. The different types of steel bracing systems tested during this study are X bracing, diagonal bracing system, inverted bracing system, and zipper bracing system, and the various RC structures used during this study are 3-story building, 5-story building, 9-story building, 12-story building. Keywords: earthquake, pushover analysis, steel braced, seismic, retrofitting. Introduction. The steel bracing system is one of the methods of retrofitting system intended to insert the existing structures that damaged during the earthquake. The function of the steel bracing is to resist the lateral loads acting on the building. Lateral loads are the forces coming from the wind and earthquake wave when they act to the structure. Steel bracing commonly made on a steel, and it helps the structures for protection of the lateral loads, and also it takes part in the energy dissipation within internal tension and compression during the earthquake. Structural elements like column and beam they help the structure from the loads that coming in the vertical direction, and the function of the steel bracing is the protection of the horizontal lateral loads. The inserting steel bracing depends on the type of damage of the structure, but commonly, steel bracing is used to put in the openings between the vertical elements, but steel bracing can be internal and external. It depends on the condition of the building. There are two types of steel bracing, and they are concentric steel bracing and eccentric steel bracing. Therefore, this research is concerned the concentric steel bracing system. There are two types of concentric bracing system, and they are concentric steel bracing, CBF, and the special concentrically bracing, SCBF. The difference between these two concentric systems are, SCBF can absorb more deformation in tension and compression than CBF. SCBF uses to give the soft story stability for the seismic loads that acting on the building. Objectives and scope of this study. The importance of this investigation is to assess the performance of the concentric bracing system during seismic activities. The performance of the steel bracing in the RC buildings is analyzed by SAP 2000. The following are the objectives of the study. The enhancing the safety of the existing structures that harmed during the seismic tremor. Checking the performance of the various types of concentric steel bracing system through the existing RC structure. Evaluation of the impacts of the horizontal loads acting on the building. Increasing safety against the horizontal loads that are acting on the structure during the seismic activity. The pushover analysis method. This method is applying direct lateral loads on the frame, starting from 0 to a value of corresponding to an exact displacement level and determining the possible weak members and the failure members of the structure. The performance of the building is evaluating by using hinges position at the target displacement or the performance point corresponding to an exact earthquake level. The acceptable performance is the demand is less than the capacity of all the hinges positions, as the loading and assessment procedures are only virtually correct concerning the real earthquake hazards. 1. History of pushover analysis. The list of the researchers studies the pushover method are as follow. Fachfart and Fischinger 1987. These researchers propose the N2 method as a nonlinear procedure is appropriate to design the regular building oscillating mainly in a single mode. CSM, Capacity Spectrum Method approved ATC 40, ATC 1996, was the first introduced in the 1970s through Freeman as a quick assessment procedure for the evaluation of vulnerability structures during the earthquake, Freeman 1975, Freeman 1978. The analysis procedure is compares to the capacity of the building in a curve called pushover curve and the demand of the ground motions under construction in the way of elastic response spectrum. 2. Mani 1993, this researcher proposed the acceleration displacement response spectrum, ADRs, that the spectral acceleration versus spectral displacement is plotting in a curve, with the period, t, stands for the radial lines. The crossing of the capacity spectrum and the demand spectrum make available of the displacement demand and the inelastic acceleration. The capacity spectrum method was updated, FEMA 440 2006.3. The Federal Emergency Management Agency first introduced coefficient method, CM, in the USA, FEMA 273 1997, and then developed a pre-standard for the rehabilitation of the structures and seismic hazards, FEMA 365, 2000. Later this method is updated into FEMA 440, 2006. Assessment of the pushover method procedure. The pushover procedure performed to the analysis of the lateral base shear and the roof displacement relationship of the building. The pushover curve for the structure, including the initial linear, in which the frame members are deforming in their elastic behavior to the inelastic region, where the beam and the column members start developing plastic hinges. If the lateral deformation continues, the other plastic deformation happens to the structure. Modal pushover analysis, MPA. This method has been establishing to account for the more significant mode effects. This analysis method is highly exact if the building is very deforming into the zone of stiffness and failure in strength. This method is making on the supposition of the standard model analysis that extended into an inelastic system. The seismic response is determined in the modeling development of the seismic effects by pushover analysis using force distribution in each mode. The calculation of the complete reaction of the structure is obtaining by combining these model responses through the SRSS model combination method. Methodology. This part is the modeling and base shear analysis of the structures. The most significant part of this is about designing the RC models and checking their strength by SAP 2000 programming. SAP 2000 programming is utilizing the RC model during this study, and it's using for checking the quality and limit of the structural components before reaching the highest expecting displacement of the model. The analysis method used during this study is a pushover method. Displacement during pushover analysis. The force displacement method shows that the displacement modification curve below has higher precision and can be used for tensile frames through a computer because the computer software can't do displacement based for the pushover method. So, the displacement force method must be making, even if it has lower precision. The computer analysis will adjust the incremental dynamic, which represents 2% of the displacement process, to decrease the variation of the pushover curve in the building response using the pushover method. Also, to get the nonlinearity behavior of the building, the pushover curve must be defined. 4.5. Plastic hinges. The occurrence of the plastic hinges is the building by using the pushover method will vary according to the know of story, also the type of bracing system and the type of plan shape of the structure. The plastic hinges will reach different limits according to the deformation of the steel bracing system because of the failure moment under ground motion. In this study, plastic hinges will be under 3 properties. IO, immediate occupancy, LS, life safety, CP collapse prevention, A, B, C, D, E according to the condition of the hinges. This part, the comparison between the same no of stories and the planned shape, will be analyzed by the pushover curve on the x and y axis. 4. Modeling. This model is existing residential RC buildings, located in Gazamagasa, North Cyprus, designed with 10% probability of being exceeded in 50 years or 475-year return period. 34. The properties for the geometrical plan. The properties for the geometrical plan dimension. The floor plan dimension is 31 square meters. The base width and length of each room are 36 square meters. The height of each story is 3.5 m. The building type is a residential structure. Steel bracing system. The function of the steel bracing is to protect the structure the earthquake loading. Also, steel bracing system increases the strength of the RC building. After more research and application, this idea has become more relevant for seismic protection because of the simplicity of the implementation, and it's more relatively cheaper than the shear wall. For example, Shugano and Fujimura performed a series of tests on a frame model of one story, which had been strengthened by a steel bracing system. They compared with a masonry infilled wall. They aimed to understand the effect of each of these systems. Then, they found that the steel bracing system has more strength than the masonry filled wall during the seismic activity. 8. Concentrically and eccentrically braced frames. Steel bracing system is designed primarily to resist the earthquake and wind loads. The members of the steel bracing are intending to work in compression and tension like the truss. Steel bracing members decrease the shear force in reducing the bending moment on the columns and the beams in the structure. Also, they decrease the lateral displacement of the building. The earthquake loads are shifting as an axial load in the steel bracing members. It's possible to use different kinds of an eccentrically bracing frame like K-shaped in the global bracing along with the building height. Sometimes it's possible to use concentrically steel bracing systems like X, V, Z, diagonal bracing inside the vertical members of the structure. Result. SAP 2000 is utilizing to compute and check the performance response for the various types of steel bracing. The type of structure selected during this study is an RC frame. The pushover method is applying to the models, then, the result is plotting into a curve. The purpose behind choosing this strategy is checking the performance of the steel bracing and its strength. During this investigation, SAP 2000 is utilizing to examine the response performance of the different types of CSB steel bracing when it's been using to the existing RC structure. This study, each CSB steel bracing, has made different displacement, and their strength was different from each other, but the unbraced frame joints are not stiff enough, and failure happens, so the unbraced frame becomes the weakest frame compared to the other frames. The result is showed to a capacity curve figure 7, so the curve is clearly defining that the inserting steel bracing in the existing structure is dramatic, increases the strength of the building and allows the building to stand with high lateral loads. 9. Interstory drift. The interstory drift ratio is the maximum percentage drift between two floors divided by their story height. The result of this study shows that the inserting steel bracing system structure decreases in peak interstory drift. Story drift for both braced and unbraced structure is shown in figure 9. The result shows that the upper stories is decreased in a fairly linear manner. Top floors have lesser story drifts compared to lower story drifts because of their low displacement values, when it's inserted the steel bracing, and the interstory drift of the first story is less than the second story interstory drift, which should not have been the case. Displacement of the different types of steel bracing system. The comparison of the dynamic load displacement in the x direction for the different types of steel bracing is comparing during this research investigation. This investigation proves that the top story floors have greater displacement than the lower stories. Also, this study shows that the uses of steel bracing in the building frame it dramatically decreases the effect of the lateral loads and story displacement. During this investigation of the comparison of the different types of steel bracing is made to know the most irresistible during the seismic activities. So, X bracing becomes the most useful and good reductions of story displacement. Therefore, the X bracing was helpful to the structures. Also, as the height of the structure increase, the range of the movement will decrease when it's used steel bracing system. Conclusion. During this study, various types of steel bracing systems have been analyzing as an effective method in the form of retrofitting in the existing RC building. The different various of steel bracing that selected during this study are X bracing, inverted bracing, zipper bracing, and diagonal bracing. This research of the various type of steel bracing has been tested by checking their strength limit of the existing structure. During this study, there are differences in height models selected, but in this article, only 5-story building is showed, which is utilized and analyzed by the SAP 2000 program. The pushover method is applied through all the model. So, the result of this study shows that the X bracing system was the most irresistible during this study compared with the others. X bracing system increases the strength of the structure. Also, it takes part in the energy dissipation of the frame. This result shows that in braced frames the sequence of hinge formation is first in the brace member, after that in the column and then in the beam. So, if it increases the joint stiffness and column stiffness, it will reduce axial deformation of the structural elements.